problems or algebraic formulas, how we can create these formulas and how we can use this. So let's watch. Algebraic formulas or in other words algebraic properties. So this is related with ratios. So take four numbers A, B, C, D, which are in proportional. They are in this way. We have A is to B, C is to D. So the first is that we can put this that A is to C is equal to B is to D. So how we can prove this? We have A is to B, C is to D. So you can write down A by B is equal to C by D. So we can just replace C by B and B by C. Then we will have A by C is equal to B by D. So it implies that A is to C is equal to B is to D. So you can write down A is to C proportional to B is to D. Now this is one of this property. Another property is that if this is true, means if A is to B and C is to D is true, then we have A plus B is to B, C plus D is to D. This is also can be proved by this. Given that A is to B, C is to D. So you can write down A by B is equal to C by D. We will add 1 in both sides. A by B plus 1 equal to C by D plus 1. So we will have A plus B by B equal to C plus D by D. In ratio measurement, this will be A plus B is to B, C plus D is to D. In this similarly, we can also prove that A minus B is to B, just subtracting minus 1 from both the sides. We can prove that A is to B is to B C minus D is to D. Now the third property is dividend procedure or component dividend procedure. If we take this is 2 and this is 1, or this is 1, this is 2, and divide 1 divided by 2, then we will have A minus B is to A plus B this will be C minus D is to C plus D. This is the well-known component dividend procedure. It can be established in this way. Now we can take an example also. If four numbers 2, 6, 8, 24, they have a ratio 2 by 6 is equal to 1 by 3, and 8 by 24 is equal to 1 by 3. So we have the relation 2 is to 6 and 8 is to 24. So by dividend component dividend procedure, you can write down that 2 plus 6 by 2 minus 6 is equal to 8 by minus 4. This is equal to minus 2. And on the right hand side, 8 plus 24 by 8 minus 24 is equal to 2 minus 16. This is equal to minus 2. This is an example of the component dividend procedure. And this is also 2, means A plus B by A minus B is equal to C plus D by C minus D. If A, B, C, D, we take A this number, B this number, C and D these numbers, then we have this component dividend procedure. And another procedure is if A is to B is equal to C is to D is equal to E is to A, then we have A plus C plus E is to B plus D plus A. So this can be also very easily proved. To prove this, here I have written A is to B equal to C is to D equal to E is to A equal to A plus C plus E by B plus D plus A by B is equal to C by D is equal to E by A. If this is true, then this is also true. So by component material the procedure we have if we take these are true, that this is true for K, then we have A is equal to BK, C is equal to DK and E is equal to 8K. And if we find out A plus C plus E which is equal to BK plus DK plus 8K, and if we take K common, we will have B plus D plus A, and in ratio form this will be A plus C plus E by B plus D plus A equal to K. So you can look this ratios which is equal to K, and this ratio is also equal to K. So you can write down that A by B equal to C by D is equal to E by A is equal to A plus C plus E by B plus D plus A. So it is true for infinite number of ratios. A by B equal to C by D equal to E by A equal to dot dot dot. Then this is true for A plus C plus E plus dot 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 as B plus D plus A plus dot dot dot. It means that it is true for infinite number of ratios. Thanks for watching.